we talk about poultry housing for raising all poultry, whether it's turkey, quail, broiler, chickens, breeders, layers, there's similar needs that have to be provided for these birds. And it's going to be things like temperature control, air quality through proper ventilation, feed, water access, lighting, and protection from disease. And these things are going to be common to get that optimal bird performance. So there's an interrelationship between bird performance, bird health, and bird welfare. One of the important points to this is going to be managing the house correctly and to give you that optimal environment to meet those needs. Another important aspect of poultry management is good biosecurity. And what we want to do is control traffic that's coming on and off farms so that in case anything does happen, we can track that back. But one of the things that poultry farms typically tend to do is they minimize the number of visitors. Only people that need to be there are going to visit that farm. They're going to have specific areas for the cars and trucks to travel down. There's going to be specific areas for you to park. Whenever we come up to the farm, we're going to go ahead and don our PPE. This is our personal protective equipment. And this is all being done not to protect you. We're doing this to protect the birds. We're trying to make sure that we don't become a biological vector that's bringing some virus or bacteria into this house and exposing those birds. When it comes to management, and we're moving around and having to work these different houses on a farm, there's a certain order from a biosecurity standpoint that you want to go. If you've got a house that might be questionable on health, then that house would be one that you want to visit last and move from the houses where you don't think there's any problems to those. So that way that you try to isolate that as best as you can and not transferring it between all the houses. If we end up having to visit multiple farms during the day, then we're typically going to move from younger to older, not the other way. We don't want to bring something back to a younger bird that they may not have developed immunity for yet. Whenever we've got good biosecurity, it can't be replaced. Biosecurity is an important part of a good management program for a farm and is critical to making sure that we get optimal performance and welfare and health for these birds. Providing feed to birds is one of the most important things that we do when raising poultry to market age and market weight. We're going to bring this feed in from these storage bins that you see outside to the hoppers that are located in the center of the house, and then it's moved down to the feed line. At the end of each feed line is a control pan. As the birds empty that pan, it will turn on and automatically feed these birds and fill these lines up. The other thing that we can do is turn the feeders on manually, and times that we do that is during brooding. During brooding, we're going to put out extra feeders in between the automatic feeders, increasing that feeder space, making it easier for them to find food and get started on feed as quickly as possible. And that is one of the key things to getting poultry off to a good start, is making sure they find that food in that first few hours of placement into the house. There's a lot of different types of feeders out there. There's a traditional square tray. Some people will put paper down under the feeders and put feed on that. A lot of times we raise the feeders as the birds get older to minimize feed wastage and to keep them from kicking too much of the bedding material into the feeders. So as you visit poultry farms and get into these poultry houses, you're going to see a variety of different types of feeder systems, different brands, but they're going to have very similar attributes as we discussed in this video. Providing water to birds is just as important to feed, if not more important. They can actually go longer without feed than they can without water. When we bring the water into the house, we need to make sure that the birds have got an ample volume of that. Just like we do with feed, we're going to provide unlimited access to that. So we start off by bringing the water into the house, and there's a water panel in the control room that regulates the pressure. If we need to add some kind of vitamin or mineral to the water, or even a sanitizer, we can do that through the medical dedicator system, and we bring that into the house. These birds can access that by triggering these pins at the drinkers. This system is controlled by a regulator at the beginning, so they have constant water in this line. The birds just keep triggering that pin and they can drink until they're satisfied. So as we raise these birds, there's some key things that we have to do from a management perspective. These systems have to be raised. As the birds grow, we got to make sure that these birds are slightly reaching up to get the water. Because if you watch birds drink, even when they're drinking in the wild, they're going to go down, they get the water, and they're going to tilt their heads back. And so what we do is we just want them to reach up and trigger that pin and have the water consumed. The other thing that has to be adjusted as we raise these birds is water pressure. As the birds get older, we're going to increase the water pressure, which allows them to get more water whenever they trigger that pin. So these drinker systems are designed to provide unlimited access to fresh, clean water. Bedding material is one of those things that most people don't give a lot of thought to. Bedding material serves a lot of functions in a poultry house. It helps absorb moisture. It helps to dilute manure as the birds scratch it around. It actually provides some insulation from the packed dirt floor. It actually will also cushion. They're not stepping down on a hard surface all the time. So there's several types of materials that are used that are common. Pine shavings, sawdust, straw, peanut hulls, rice hulls are all very popular materials that are used throughout the U.S. and North America. And what we want to do is when we're taking a look at litter quality, number one is litter depth. Minimal depth is going to be around 3 to 4 inches of litter. We're trying to control the moisture in that litter. And this is a good example of some dry, friable litter. Friable is a litter that's dry, it's not clumped together, and it just kind of falls through your fingers. And it's in good quality. What we want to avoid is caked litter. This is getting hard, compacted. There's a lot of moisture here. There's a lot of nitrogen here. And this is going to be an indication that we haven't done a proper job of managing the house. It could be a number of items such as drinkers management. It could be bird density, how well you did keeping the birds spread out. And it could be poor ventilation as well. So all of those attributes minimize this caked up litter and promotes that more friable litter. And why do we care about litter quality so much? It's because of the environment. This is a source of ammonia for most operations. We want to try to minimize that from an air quality standpoint. Poultry companies have to undergo third-party animal welfare audits. One of those aspects in those audits is not only how does the floor look when they come in here, they're looking to see how much caked litter they have, but they're also looking at lesions, foot pad dermatitis on the bird's feet. That typically tends to be associated with higher moisture and more caked litter in the house. A lot of the times they're not going to assess that foot pad dermatitis in the house, but they will look at it at the processing plant. And if they see a lot of foot pad lesions, they're going to assume that this was managed poorly. In the end, what we want to do is make sure that we keep a good control over our bedding material. That's a lot of focus when it comes to just environmental control, is trying to make sure that we do a good job of maintaining this litter quality so that we minimize that foot pad dermatitis and hopefully minimize the impact it has on air quality. Air quality is another basic need of poultry that we need to do a good job of managing. Air quality is going to consist of parameters such as carbon dioxide, carbon monoxide, ammonia, and relative humidity. For carbon dioxide, we want to maintain that at 5,000 ppm or less. For carbon monoxide, we want 50 ppm or less. For ammonia, 25 ppm or less. And then relative humidity, we want to shoot for a range of between 40 and 60%. If we do a good job of controlling that relative humidity, the other air quality parameters are usually pretty good because they kind of track with relative humidity. Carbon monoxide, I'll just point out, is not really a ventilation issue because it's more of a heater maintenance issue. Carbon monoxide is produced from the improper combustion of propane or natural gas, which is our major fuel source for heating systems. Ammonia is one of the other most important air quality parameters that most poultry facilities are going to monitor. And the reason that is because it's being being produced from the floor, and we know if we're not doing a good job of controlling the litter quality, we're going to have high ammonia levels. In order to control all of that, we're going to control relative humidity and try to maintain that between 40 and 60%. So if we do a good job of controlling relative humidity, the other air quality attributes will follow that relative humidity and provide that optimal environment for good bird welfare, performance, and health. So when you're going into a poultry house and evaluating not only the poultry house environment, but you're also going to be looking at the birds. They're going to tell you a lot about the environment. And one of the things you want to do when you walk into the house is watch to see how the birds are spread out. Hopefully you're seeing them spread out evenly. You don't see a bunch of birds clumped together and huddling like it's too cold. And hopefully you won't see a bunch of birds sitting in there panting either. So what we want to do is watch those birds, watching them drink, watching them eat, watching the way they distribute. Other things besides activity could also be vocalizations. When you walk into a house, you can actually hear situations where you might have a little bit of a respiratory issue, or they may be indicating a health issue just because of the volume or the type of vocalization you hear when you walk into the house. And a lot of times when you walk in there too and it gets really quiet or something, it might also indicate that something's changed. You will also see that with bird activity. Certain changes in management, such as changing the ventilation rate or doing something a little different than what the birds have been seeing the last few days, will cause them to change their activity just briefly. As they get used to it and as they move around, that bird activity can give you a lot of insight into how well you're doing in managing that house and be providing those basic needs of those birds.
Modern poultry houses are built with a fairly sophisticated environmental control system, which in many ways is not that different from the typical house or apartment. The fact is, well over half of the cost of building a new poultry house is associated with making sure we can keep our birds as comfortable as possible, regardless of what is happening outside. During cold weather with baby chicks, our houses are designed to maintain a house temperature of 90 to 95 degrees, while at the same time making sure that humidity, ammonia, dust, and carbon dioxide levels are kept to a minimum, whether it's 70 degrees outside or whether it's 0 degrees outside. Now, with older birds during hot weather, our houses are designed to maintain a temperature of between 75 and 85 degrees on the hottest summer day. Even if it's 105 degrees outside, our house will be between 75 and 85 degrees, and we're going to have a nice breeze of about 8 miles an hour blowing over these birds continuously, keeping them as comfortable as possible. Now, one very important aspect of our environmental control system is the fact that our houses are totally enclosed. This provides the grower with increased level of control over air temperature, air quality, air movement, light, and as well as keeping energy usage to a minimum. Because our houses are totally enclosed, one of the big advantages is they're going to use 30 to 50% less heat or energy compared to our curtain-sided houses of 10 or 20 years ago. Furthermore, during hot weather, they will require 10 to 20% less electricity to cool the birds over traditional curtain-sided houses, basically making them a very green way of growing birds. Another important aspect of a modern broiler house is they tend to be large. Larger houses tend to have a more stable, more consistent environment than the smaller houses built in the past. Larger houses tend to have a lower energy cost per square foot per bird placed. So we're going to have lower electricity bills and lower heating bills. Last but not least, larger houses tend to have a lower initial cost, both to build and to equip, than the smaller houses built in the past. We're building these houses to gain control over the environment, because if we have control over the environment, we'll have control over the bird comfort, bird welfare, energy cost, and production of that bird. So it's all about keeping conditions right for the bird. An environmental control system consists of many parts, and one of the most important aspects of an environmental control system is our cold weather system, something we can use during cold weather with small birds or large birds, where our outside temperatures are much lower than we want it to be inside. We need to have a system that will be able to heat and bring in fresh air to keep our birds comfortable. Now, our cold weather environmental control system basically consists of heaters, exhaust fans, sidewall inlets, and circulation fans. The heating system, there's a couple different types. The air in the poultry house needs to be warmed by either using forced air furnaces or some type of radiant heater. Now, forced air furnaces are pretty straightforward. It's not that different from what you would have in your residential house or apartment. Basically, it's a system that just heats the air in the house up to the temperature where we want it. With baby chicks, again, that could be 90 or 95 degrees. Now, radiant heat systems are a little bit different. It's sort of like sunshine. On a sunny day, it's cold outside, the sun comes out, you can feel that heat, which heats both the floor and the birds directly. Because we're heating the floor, we're going to get some drying of that litter, so we minimize the production of ammonia and we have nice dry litter for those birds to walk on. We also want to create a floor temperature gradient because we want the birds to choose what temperature they're sitting in. So if they get close to the brooder, the floor temperatures are hotter. They move further away, the floor temperatures are lower, so the bird can self-regulate. We don't have to tell the bird what it wants. The bird can select what it wants. Now today, the most common form of radiant heater is the tube heater. They're long tubes, anywhere between 10 and 30 feet long. They tend to be towards the middle of the house so they can heat that floor and a little bit less radiant heat on the outside. When it comes to the cold weather environmental control system, one of the most important components, of course, is the heating system. Because with that heating system, we're able to make the conditions at the floor what the birds want, regardless of what's happening outside. So again, it's about bird comfort, welfare, health, and all we can do during cold weather to make sure the bird is as comfortable as possible. One of the most important aspects of an environmental control system is we need some way to bring in some fresh air. We need to bring in fresh air, not just to control air quality to keep our birds healthy, but we also need to be able to bring in fresh air to control the house temperature, because the hotter it gets, the more heat the birds produce, the more fresh air we have to bring in to maintain a consistent temperature. When it comes to a negative pressure system, one of the most important aspects are our exhaust fans. We generally have two different types of exhaust fans. We have our sidewall fans, which tend to be something like a 36-inch fan that are primarily used during cooler weather or with younger birds to control air quality. Now, most modern houses have tunnel fans. They're called tunnel fans, but they're actually used just not for tunnel ventilation or hot weather ventilation. They're also used during more moderate weather to bring in air to control our house temperature. We have our exhaust fans. What do? We turn them on and they create a low pressure zone within the house, or a partial vacuum. We also have air inlets. So the fans create a low pressure zone and we have air inlets scattered down the house. Now what happens with that low pressure zone is air will enter through all the inlets in the house to fill up that partial vacuum. So again, negative pressure, air comes in through our air inlets to offset that negative pressure. How fast the air comes in through those openings controlled by the amount of pressure. If we have a low pressure, the air will come in slowly. If we have a high pressure, the air will come in quickly. What we want during cold weather is for the air to come in quickly, because when it comes in, it's heavy relative to the air inside the house. Hot air is light, cold air is heavy. So the air comes in, we want to make sure we shoot it along the ceiling so that it heats up before the birds ever see it. The amount of pressure is controlled by a machine. We set a certain static pressure range, usually between something like a 0.07 to maybe a 0.12, and within that range we'll have the air come in with sufficient speed to make it all the way out to the middle of the house before dropping to the floor. As more fans come on and more pressure is created, the inlets will open up more. One of the most important components of our negative pressure system are the sidewall inlets. The sidewall inlets are typically located evenly down both sides of the house, positioned right next to the ceiling, and they're used during cold and mild weather. for air quality control and temperature control. What we want to be able to do is use an exhaust fan wherever it's located and bring in fresh air uniformly throughout the house so all the birds receive an equal chance of getting a nice, clean environment. Now, one of the important aspects of bringing the air in through our inlets is as the air goes along the ceiling, it mixes with the warm air produced by the birds and our heating system. So it might start off outside at 30 degrees. If we can get it all the way out to the middle of the house, generally it's going to be very close to room temperature. So when that air moves down to the floor, the birds don't realize it's cold outside. All they're feeling is a nice, fresh breeze coming down. Now, how do we know how much fresh air to bring in? Again, we have to control air quality and temperature. Now, when it comes to controlling air quality, the primary thing we're trying to control is humidity. We want to keep the humidity generally between 40 and 60%. So what we try to do is run those fans enough to control that humidity so we're not going to have a lot of ammonia, wet litter, and bird health issues, but not so much as to use an excessive amount of fuel. The other aspect, of course, when it comes to those exhaust fans and our air inlets is temperature control. As the house temperature starts to warm, we start turning on more fans. And since our sidewall inlets are controlled by negative pressure, as more fans come on, it creates more of a negative pressure, the machine responds and opens up the inlets accordingly. So, exhaust fan operation is controlled by both air quality and air temperature. What we're trying to do, we start off with our fans on a timer, bringing in fresh air just to maintain humidity. As it gets warmer and warmer, we turn on more and more fans. And our inlets in this process are responding to the pressure created by the fans to bring in just the right amount of air to meet the needs of those fans. So it's all about control. The negative pressure system gives us control over air quality, gives us control over air temperature, which gives us control over bird performance, health, and welfare. Another important component of our cold weather environmental control system are circulation fans. Circulation fans provide supplemental mixing of the air in the house. Why do we need mixing? Well, first, during brooding, especially during cold weather, the hot air produced by our heaters, a lot of it ends up next to the ceiling. The circulation fans help to move that hot air off to the ceiling where we don't need it, down to the birds where we do need it. Secondly, by moving that hot air off the ceiling down to the floor, we need less heat to keep our birds comfortable. We're just utilizing what we put in the house better. We also get litter drying, because not only is the air nice and hot next to the ceiling, it tends to be nice, hot, and dry. What is it going to do next to the ceiling? It's hot, dry air next to the ceiling. No, we want our hot, dry air next to the floor. So by taking that hot air off the ceiling, moving it down to floor level, we're not only warming the litter and warming our birds, we're drying the litter. Last but not least, what circulation fans will do is help us to create a more uniform environment within the house. We want all the birds to have the same air temperature and air quality, and we want them all to have dry litter. So circulation fans are another component of an environmental control system that allows us to minimize fuel usage, make our floor temperatures nice and warm, keep the litter dry, keeps our birds healthy, and our performance to a maximum. To ensure our birds are comfortable during really hot weather, we utilize tunnel ventilation. Tunnel ventilation, quite simply, is having large exhaust fans on one end of the house and a large inlet at the other. We pull the air from one end of the house to the other in less than 60 seconds, totally exchanging the air in the house, which means there'll be less than a 4-degree temperature difference between when the air comes in and when the air goes out. Secondly, not only do we exchange the air rapidly, we get a high airspeed, and it's a uniform airspeed in the house. No matter where we are in the house, the birds are going to receive an airspeed of between 600 and 800 feet per minute, which provides a wind chill effect of roughly 10 degrees or more. So even though the thermometer may indicate that it's 85 degrees, that air moving over the birds makes those birds feel as if it's 75 or even 70 degrees. Now, to supplement tunnel ventilation, we use evaporative cooling. Because when it gets really hot outside, let's say 100 degrees, yes, we can move air over the birds at a high speed, but it'll be a hot breeze blowing over them. We want a cool breeze blowing over them. And to do that, we utilize evaporative cooling pads. Evaporative cooling pads are quite simply some filter paper that water runs over. As the air goes through this filter, the temperature is dropped to usually between 75 and 85 degrees, depending upon outside conditions. So even if it's 105 degrees outside, 110 degrees, the air coming in that house will be between, again, 75 and 85, depending upon humidity. We have this air exchange, we have this cool air, so no matter what is happening outside, the birds will always feel it's like springtime in here. It's 75, maybe 80, there's a nice breeze blowing over them, keeping the air fresh, keeping the birds comfortable, maximizing the bird performance, and of course, keeping it happy and healthy. One of the most important aspects of poultry house environmental control is having a tight house. In order to maximize the control in the environment, both cold weather and hot weather, we need to have a system where all the air comes in either through the sidewall inlets during cold weather or the tunnel inlet during hot weather. Those are the only two places we want air to enter. Because during cold weather, if we have a lot of air coming in through cracks by the tunnel fans or up by the tunnel opening or through the sidewall, that cold air isn't moving along the ceiling. It comes into the cracks, falls to the floor, and forms a blanket of cold air across the floor. We're not utilizing the hot air next to the ceiling because the air is not coming in through the inlets. So the tighter we make the house, the more air that enters through the inlets, the more air that we're bringing in that's going to be warm and dried before it moves down to bird level. So for during cold weather, we want to make sure that our curtains, if we have them sealed tightly, our sidewall doors, our end wall doors sealed tightly, those fans that we're not using, maybe we have plastic over them to seal them up so that we ensure that all the fresh air enters through inlets. And in many ways, it's not the amount of air we bring in, it's the quality of the air. So we can bring in 10,000 cubic feet of air through the cracks and we'll hurt our birds. But if we bring in 10,000 cubic feet of air through our inlets, then we're gonna help our birds because again, we're gonna lower the humidity, keep the air fresh, and keep the temperature at bird level just right. Now during hot weather, it's also important for the house to be tight because we want all the air to enter in through our evaporative cooling pads and our tunnel inlet. That's only the air that comes through our evaporative cooling pads that's going to be chilled to maybe 75 to maybe 80, maybe 82 degrees during really hot weather. All the air coming through the cracks could be 100 degrees. If it's a crack next to the ceiling, it could be 130 degrees. So again, house tightness is what it's all about. During cold weather, we want all of our air come through our inlets. So we have to make sure that everything is sealed up. During hot weather, we want all of our air to come in through our evaporative cooling pads so we can maximize the cooling and comfort our birds no matter how hot it is outside. The last and most important component of an environmental control system is the environmental controller. The environmental controller controls and coordinates all the environmental control system equipment within the poultry house. In a way, it's like a thermostat. You set the thermostat and then the thermostat controls the equipment. But in a controller, there's a lot more involved. We set the temperature we want and then the environmental controller will sense the temperature throughout the house, turning on the right number of fans, opening up the inlets, transitioning the tunnel to be able to maintain those conditions. It also helps us control air quality. We can have it set to run a fan a certain amount to control that humidity. As the humidity goes up, we can manually increase the time the fans run, or we can let the controller bump up the amount of ventilation based on humidity levels. So it's controlling the fans, it's controlling the inlets, it's controlling the evaporative cooling pads, it's controlling the lights. It's also controlling the feeder. So really that environmental controller is the piece of equipment that ties everything together, that coordinates the operation of all the equipment in the house. Now also what it does is it collects data. It lets us know what the temperature was in the house last night. Was it too hot? Was it too cold? It will give us alarms if the temperature's too high or too low. It will give us alarms if we run out of water pressure, if the feeders run too much. So it gives us the data of what's happening in the house, and it also gives us the data to activate alarms. So that controller is like the brains of the house, basically controlling and coordinating all the equipment, collecting data, and giving us alarms in case something is not right when it comes to the environment within the poultry house.
The topics that we have covered are just scratching the surface of modern poultry production. The goals are to provide these optimal conditions to get that ideal bird growth, feed conversion, bird health, welfare, and we want to do this in an efficient manner. We have plenty of resources available from poultry newsletters, spreadsheets, and even our app Poultry 411. For more information and further education on these topics, feel free to visit our website, poultryventilation.com.